started, please. Welcome, welcome, welcome to the first day of class. My name is Doug Shook. Professor Shook, you can call me if that's more comfortable for you. I am the lead instructor for this course, which is CSE131 or 50110, depending on which version of the course you signed up for. It's the same class as far as I'm concerned. And yeah, I'm the one who's going to be up here talking to you about computer science every Monday, as well as in the labs, depending on which day you signed up for, either Wednesday or Thursday. And I couldn't do it alone, so this is a very big class, as you can see. And actually, I've got another section right after this one. So there's a whole couple hundred more people coming after you all. We've got over 500 people total this semester. It's a very, very big class, as you can tell. So I've got another instructor, Dr. Tabaki. She's not here today, but you'll definitely see her in the labs on Wednesdays and Thursdays. And then I've got a whole army of TAs, I think over 100 this semester, including the two head TAs, Vicky and Dorian. You'll definitely be seeing them around in the labs on Wednesdays and Thursdays as well. But let's go ahead and get started. I like to start out just by making things very clear right off the top. Everybody is welcome here. Everybody who's sitting in this room is welcome here to take this class. Welcome to be here in this room learning computer science. I mean that in a couple different ways. So there are some of you who have probably already had some programming experience. There are some of you who maybe have never written a line of code in your life. And some of you maybe in between, right, who've dabbled a little bit but never taken a formal class or anything like that. That's okay. All of those backgrounds are okay here. The class, I will say, is specifically intended for people who have never written a line of code in their life. So if you have written some code before, you have a head start. That's not a bad thing. That doesn't mean you're wasting your time. It just means you got a little bit of a head start. So that's kind of a good thing. If you're really good at coding, you might be wasting your time here. You might be able to test out of this class and take some upper level computer science classes, especially if you got a good score on the AP CS exam, 4 or 5. That lets you skip this class entirely. So if you fall into that category, you might want to have a chat with me after class to talk about what your options are. But for everybody else, this is the spot to be if you want to learn how to program, whether you've never written a line of code before in your life or whether you've written several programs or anything in between. The other thing that I mean by this statement is to acknowledge the fact that I am a cisgender white guy in a field, tech, that is dominated by cisgender white guys, right? I don't want anybody to feel like that they're not welcome here because of that reason. In fact, I hope that starts to change over time, and the field of technology gets to be as diverse as the classes and the people that I see walking around this campus. That would be great. So I want to make it absolutely clear that while yes, tech is an industry that's dominated by, traditionally dominated by people who look a lot like me, and I acknowledge 100% my privilege that allows me to stand here before you today. That does not mean that you will not be able to succeed in computer science if you do not look like me. In fact, plenty of people have since started breaking the tradition of tech being dominated by typical white guys like me. So everyone is welcome here, and if for any reason you don't feel welcome here, regardless of whether it's because of your coding ability or your socioeconomic background or anything like that, I hope you can come talk to me about it so that we can make sure that you do in fact feel welcome here. We want anybody who wants to learn computer science to be able to take this class. It's very, very important. Let's talk a little bit more about me, my computer science background, as well as my background here at WashU. This is my 14th year teaching at WashU, so I've been doing this for a little while. I'm an old millennial. I've got 2 kids. You're going to hear me talk about them a lot because they are my world. They actually just started school today as well, but they're in first grade and preschool, so it's a little bit different than the kind of school we're talking about here. As far as coding goes, this is my first coding memory. I remember as a kid playing this game. Does anybody know what this game is? No, it's not Donkey Kong. Good guess, though. It's a game called Gorillas. It's a game called Gorillas, and it's written in a language called BASIC. Would have come out probably, I don't know, late 80s, early 90s. Like I said, I'm an old millennial, so that was kind of my childhood. And it shipped the code with the game, so not only could you play the game, but you could actually see the code that was used to make the game. And this was fascinating to me as a kid. My dad set me up on the computer and found that before long I was spending more time hacking the code than I was actually playing the game because I was having so much fun playing with the physics. The goal of the game, by the way, there's two gorillas, which you can see. You're throwing exploding bananas at each other, so you get to enter, velocity and an angle, and then the gorilla throws the banana. There's wind you have to take into account, and all that fun stuff as well. So yeah, what happens if you tweak gravity? What happens if you make the gorillas super buff? What happens if you make the explosions of the bananas really big? All that kind of fun stuff. That's how I got introduced to programming. And actually, that's pretty typical from what I hear for a lot of people. Games are their introduction to programming. And that's great. We're going to be talking about games in this class as well, but so many other things that you can do with programming. So when I went to grad school, I actually designed digital cameras and was making digital cameras instead. Cameras that could, for example, somebody's on the operating table, take a picture. I want to be able to identify from that picture where any tumors might be on that patient, for example. So that was the kind of stuff that I spent working on in grad school. These days, though, it's mostly games. I make something called randomizers for a game called Zelda 2. I'm actually a Zelda 2 speedrunner. I play a lot of video games. Had the world record for like a minute. So yeah, play a lot of video games online. And actually, a lot of my coding activities outside of work are game related. So if you're interested in that kind of stuff, I'd be happy to talk to you about it. But I know that a lot of you are interested in coding for other reasons, not just video games, right? So you're interested in coding because you're into biology and you want to do genetics or some other kind of biology research. Or you're in the business school and you want to figure out how to use coding to help you make smart stock trades, things like that. All kinds of reasons for people to take this class. And so that's really, I think, the most fun thing for me to hear about what everybody else is interested in coding about. All right, now we got to do the typical first day stuff, the syllabus stuff. I'm going to spend the next section of time kind of going over the expectations of this class, how this class is going to operate, how this class is going to run. And we'll take a look at Canvas, where all of the information regarding the class is, just to make sure that you know what to expect. This is a little bit of a different class than you might have taken before, but there is a rhythm, there's a flow. So every week is a module, roughly, and that starts today, on Mondays, with the, it's not really the introduction, but rather a review session of that week's material. I'm going to oftentimes I'm going to expect you to actually review this material yourselves before coming to class on Mondays, and I'll show you what I mean by that a little bit later on today. There's some exercises I'm going to ask you to do, but this is sort of how you get introduced to the topic, right? These aren't graded. I don't take attendance on lecture days, but I do certainly hope that you come. I do record lecture days, so if you can't make it, you're out of town, you're sick, whatever the reason, I do record and post everything, so that will all be available to you on Canvas. Once that topic's been introduced, you're going to, this slide is not displaying properly. I just realized that that's not doing what I want. Anyway, once you make it to, that's annoying to me. Hold on a second. It's because I have dark mode on. There we go. That's better. Sorry about that. Fix the text. Once we cover the material in Mondays on lecture days, then on Wednesday or Thursday, depending on which lab section you signed up for, that's when you're going to be meeting in your lab sessions. So those will be over in the Hour computer labs. The labs hold 30 to 50 people apiece. There's often multiple of those lab sessions running at the same time on Wednesday and Thursday afternoons. And in those sessions, you're going to be asked to do what we call a studio exercise. Those are in-person, in-class activities. You don't get graded on how well you do, though. So it's a time for you to talk to your peers and work together to solve a problem. We really just want you to show up to class and give your best effort for 80 minutes, right? So if you get the problem all the way done, awesome. If you don't get the problem all the way done, that's okay. If you show up and you give your best shot for 80 minutes with your peers, you're going to get credit for being there. It's basically attendance-based, right? Studios are attendance-based. We want you to show up. We want you to work the entire time. Okay? Then, once that's done, so we have the lecture on Monday. We have the in-class assignment that's not graded for completion. You just have to be there on Wednesdays. Then you have a homework assignment. So you have a week to finish that homework assignment. So it'll be due the following Wednesday or Thursday, again, depending on which class you're in. That is meant to be done on your own time. And in order to submit this assignment, you have to demonstrate it either to a TA or an instructor, either in class or during office hours. So what that means is you actually have to physically show up with the code that you have written for that assignment and be prepared to talk about it. So when I say demonstrate, I mean less demonstrate your code. That is part of it. I do want you to show me your code and that it works, but I also want you to demonstrate your understanding of that code. So the TAs are going to ask you questions about the assignment. It's almost like a quiz about your work to make sure that not only does the code that you wrote work, but you actually understand how it works. Because that's the important thing, at least to me, because the instructor, is that you understand how this stuff works, not just that it actually works. Finally, there's a little quiz. Quizzes are very, very low stakes. The actual quizzes are very, very, very low stakes. It's done online, done on Canvas. You can take them as many times as you want. You keep the highest grade. So it's really just meant as a tool to check your own understanding of the material. If you've been keeping up, you should pretty much nail it. First go, without too much trouble. Should take you a couple minutes at the most. I will also, so I know this is kind of a lot that I'm throwing at you. I think once you go through this cycle, once or twice, you'll get a feel for it, right? How this works. Every week is going to be like this. Monday's new topic, Wednesday's a studio on that topic. The following Wednesday, you'll turn in an assignment on that topic. That's how every week of this class works, except for when we have exams. So that's the one exception to the rule. Let's switch over to Canvas and talk a bit more about the course structure in that way. I clicked on the calendar first off because this calendar, Canvas is running very slowly, by the way. It must be first day stuff. I'm not entirely sure why it's going so slow. But the calendar has literally every single important event for this class on it. So every due date for every assignment, every due date for every studio, every due date for every quiz, all of the exam dates, all of that is on the calendar already. You can see exactly what we're going to be doing in this class from now until December. It's all on there. The schedule is all set in stone. So I do want to make you very aware of a few things. First off, mine's going to look a little bit different than yours because I have all 16 lab sections on here, as you can see. I'm the instructor, so I get all of the studios on my calendar. You're just going to have the one. But our first exam is coming up not until October, I believe. Maybe the second week of October is when the exam is coming up. Where is that first exam? Did I not get it on here? Let's see, that's fall break. Should be right around, I must have missed it, must be in September. There it is, I looked right past it. It's in September, it's on the 26th of September. Notice the time, the exams are in the evenings. The exams are in the evenings. They're always at 6:30 to 8:30 on a Thursday. And that time is not moving for any reason whatsoever. So please, please, please make a note there are 3 exams on this calendar, plus a final exam that I'll show you, talk a little bit about later on. But I like to make everybody aware that those exam times are in the evenings on Thursdays. I like to make sure that people mark those on the calendars towards the beginning of the semester so there's no surprises when those exams start coming up. Obviously, I will remind you. And you can see that we'll be doing some exam review sessions and stuff like that. But yeah, just pay attention to that fact. All right, let's go back and talk about the actual course policies, grading, things like that. Cool. Did you have a question? Oh, okay. All right, let me zoom in so you can actually read this. There are only 4 types of things that will be graded. So the weekly assignments, you can see there's one of those every week. There will be 9 of them. So you can do the math. Each one is worth 4.5 percent of your final grade, right? The studios, those are the ones where you just have to come to class on Wednesday and Thursday, show up, work on a problem. See, those are worth about 10% of your grade. The quizzes are very, very tiny part of your grade, right? And then the exams, those are the big ones, as I was just mentioning. However, you might notice a little bit of discrepancy there. I said there are 3 exams and a final. Yet I'm only counting 3 exams here towards your grade. You get to drop your lowest exam grade. So there are actually 4 exams, 3 exams and a final, but you get to drop your lowest one. So that is included on here later on in the policies. The other thing I want to point out, those don't add up to 100, right? That's not a mistake. That's intentional. This class is out of 102. I'm basically forwarding you all 2% of extra credit on the first day. Some people look at that and say, okay, I'm not taking the quizzes. Okay. Some people look at that and say, oh, that's half an assignment. You know, I'll keep that in my pocket, right? Okay, that's fine. Whatever you want to use that extra 2% for, that is your choice to make. But there's no extra credit in this class. The class has already kind of got some extra credit baked in. Let's talk about more logistical things. Students always like to know about late policies and things like that. So for assignments, they're due. When you come to studio on Wednesday, you'll turn in the assignment. The first thing you'll do is turn in the assignment for the previous week, right? That's when the assignments are due. However, there is some flexibility. You all get 14 late coupons, which are redeemable for 1 extra day's worth of time on a given assignment. And you get to choose when to use them. It's entirely up to you. So if you decide that you want to take a few extra days on assignment, you don't have to do anything. You can just take a few extra days on the assignment, show up to turn in your work. We'll automatically be like, oh, it's 3 days late. That's 3 late coupons, and everything will be taken care of for you in the grade book. It's all automatic. All automatic. If you don't have enough late coupons, let's say you show up really late after an assignment was due and you don't have enough coupons to cover the deficit, the TA will be like, sorry, I can't accept this. It's been too late, you don't have enough coupons to cover the late dates, right? But it's all automatic. The computer is just going to tell the TA you don't have enough late coupons, or they do have enough late coupons, I'm going to take 3 of them for submitting this assignment 3 days late, right? So that's all explained here for the assignments. For the other components of the course, the studios, the quizzes, and the exams, there's no makeup work. There's no late things, there's no makeup work, nothing like that. If you miss a studio, sorry, the studios are very heavily built around people coming and participating. I do allow you to miss 2 studios before it starts counting against you. So everybody gets 2 days where if you get sick or go out of town or whatever, right? You don't have to come to the studio for 2 days. It's not going to hurt you. If you start missing 3 studios, that's when it starts, 3 or more, that's when it starts coming off of your grade. I already talked about how exams, we drop your lowest exam grade, right? So that's why we don't really allow makeups for those exams, because you can just drop. If you have a conflict, that's going to be your drop. That being said, in a class this large, there are always going to be situations where, that I can't anticipate, right? There are 500 people in this class. I cannot possibly predict all of the things that are going to happen to all 500 of you. If you've already dropped your exam and something else happens, and you're like, oh shoot, I can't drop this exam, what do I do? Come talk to me, please, please. These policies will work for 99% of the people, and if they're not working for you, I want to hear about that. I can't make any promises, but I do want to help you. I do want to do what I can to make sure you get a grade that reflects what you know and not due to procedural stuff. Cool. Trying to think of what else I need to talk about. Letter grades. That's okay. We'll get to that in a second. Okay. Yep. Any questions about course policies before I move on to the next syllabus item? Any questions about? I know I threw a lot at you. Probably feels a little confusing. I promise once you get through a week or 2 of it, you'll get used to the flow. But if there's any questions, I can answer right now. Yeah.
Are Monday lectures recorded?
Yes, absolutely. I'm recording right now.
And where are they posted?
Canvas. Everything's on Canvas. Yep. Everything's on Canvas in the back. I'm sorry? I'm getting to that. Give me a second. We'll talk about that in a minute. Yeah.
I see there are 3 assignments, one due today, a quiz due tomorrow. Are you gonna get into that?
Tomorrow?
Yeah, it says quiz 0 due tomorrow at 3:15.
That's probably a mistake if it says tomorrow. It should be due next week. I don't see anything on my calendar for tomorrow. It does? Okay, I'll have to go change the date. That's just my bad. That should be next week. So I'll go post that to next week anyway. That's actually an important point. I'm glad you brought that up. Anything that's marked with a 0, module 0. So there's studio 0, assignment 0, quiz 0. That's all practice. That does not count. That is a warm up, right? So if you botch the first assignment 0, whatever, it's a practice. It's a warm up, right? We're giving you a dry run that doesn't count towards your grade so that you can kind of get used to the process. I'll go take a look at that quiz grade right after, or that quiz date right after class. That's probably just a screw up on my part. But yeah. Any other questions before I can hop into the next syllabus day stuff? Yes?
The Wednesday assignments turned in on campus?
No, they're turned in person. You actually have to show up to class with your code. It'll be right before the studio exercise for that day. Yep. Assignment submissions have to be done in person. Can't be done over Zoom, can't be done online. Have to be in person. Yes? I mean, I don't post slides because after today I don't plan on using them. I'm not a slides person. I'm very much going to be coding up in front of you for every other class besides this one, basically. Yeah, slides suck. Boo slides. Don't tell the other professors I said that. Any other questions? I know there's a lot coming at you. There'll be more time to ask questions in a moment. Let me go ahead and move on to some other concerns. Where am I at here? All right, yeah, somebody was just asking about AI. Can you use AI for this class? Yes, absolutely, you can use AI for this class. So I know ChatGPT is usually what people mean when they talk about AI, but there's lots of stuff out there. This is actually a relatively recent change. Up until this semester, we were not too keen on people using tools like ChatGPT for this class. As you might imagine, for an introductory programming class, ChatGPT is pretty good, right? ChatGPT is actually very good at doing the kinds of things that I'm going to be asking you to do in this class. However, I want you to note a couple of things, right? ChatGPT is not going to be present at your assignment demo. So when you come to class to turn your code in, and the TA asks you questions about your code, you're going to have to know the answers to those questions to get the grade for the assignment. You're not going to be able to look it up on ChatGPT. You're not going to be able to look it up on your phone, right? You're going to have to know. You have to know the answer to that question. And the same thing's true for the exam. You're going to show up to take an exam in about a month, right? And I'm going to ask you to write code on that exam. The best way to get better at writing code is to write code, is to practice. If ChatGPT has been writing all your code for you, I promise you, you're going to show up to that first exam and it's going to be a bad time. You're not going to know how to write code. So, you can take away from this whatever you want. Some people, I hope, are going to take away from this that while ChatGPT is a useful tool, I actually ought to try and learn this stuff and practice. Do the exercises. That's what I'm asking you to do. If you want to learn how to code, if you want to learn how to program, that's how you do it. You don't just plug all your problems into ChatGPT. That's not programming. Programming is understanding the code that you're working with, not just blindly taking what the tool spits out and plugging it into the computer and hoping that it works. I use an analogy a lot. Tools are great, but only if you know how to use them. You pick up a hammer and try to nail something in with the wrong ends, you have a bad time. If you try to use ChatGPT and you don't understand what it's telling you, you're going to have a bad time. It's not going to work very well for you. So please be cautious of how you use tools like ChatGPT to assist you. Using it to spit out the entire solution to the assignment, not what I would recommend. Can you do it? Is it against the academic integrity rules? No, it is not. But I also want to point out that whether your code is functioning or not, on the first assignment, for example, whether your code is functioning or not is worth 10 out of the 100 points for that assignment. The other 90 are the TA asking you questions about that code and expecting you to know the answer. ChatGPT can't help you with that part. That's on you, right? So, yes, use AI tools all you want. At the end of the day, what I care about is your understanding of the code. If you can have ChatGPT spit the code out and you can tell me how it works perfectly, that's great. I would suggest, though, that if that's the case, maybe you should go take 247, right? Maybe you should take 132. You already know programming if that's the case. To me, that's what that says. You already know how to do some kinds of programming stuff that you can look at the output of ChatGPT and understand what that's saying already. So if you can't, well, this is the class to do it. Try writing the code. That's what I'm trying to get you all better at, is writing code. And the best way to do that is to write code. So yeah, the AI, the academic integrity part of the syllabus is actually loosened up quite a bit this semester. I'm going to come back to that since we're already kind of talking about academic integrity. The main academic integrity points are the demos and the exams, right? At least as far as I'm concerned. Those are the two big parts. Studios are just attendance-based and the quizzes are online and they're worth barely anything. So again, it is tough. It is hard. I remember going through my first intro CS class nearly 20 years ago, thinking it was very tough. But we've been through it too. We know it's not easy. That's why we provide so many ways for you to get help. So let's back up and talk about that for a second. There are lots of ways to get help. We have TA office hours every night, except for Saturday. So 6 days a week, we have TA office hours from 6 to 10 p.m. I don't know the room yet. They won't let me reserve a room for it yet, but as soon as I know, I will tell you. They're not going to start for another week or so anyway. I have office hours as well. They're by appointment. With this many students, it is difficult for me to hold open office hours, so instead I offer them by appointment, and you can find the link to that right here. Schedule an appointment with me. Takes you to my Calendly page. It says there's no times in August. Well, that's because it's the last week of August. I actually do have times on here that you can schedule. So yeah, if you want to come talk to me about homework stuff, you want to come do an assignment demo because you weren't in class for whatever reason, that's what these appointments are for. And then we also have a message board called Piazza. I like the message board because sometimes students will email me with their problems, which is, I want to make clear, 100% appropriate if it's a private situation, right? Has to do with your health or some other kind of thing like that. Yes, please email me directly. That's totally fine. You can always email me directly. Some people email me about homework stuff, which again is okay. However, there's one of me and lots of emails in my inbox, I assure you. So if you're trying to get quick answers, oops, I'm not logged in. If you're trying to get quick answers to your homework questions, I'm probably not the, oh, what's my password? I'm probably not the guy. However, all of the TAs, all 100, some of them are on this message board, on this Piazza message board. So if you ask a homework question on here, somebody's going to see that much sooner than I will, probably. Not to say that I won't write you back. I absolutely will. I just, try to temper your expectations. Sending an email to my inbox is going to be much slower than posting something on here. So if you're really looking for help, trying to get help fast, Piazza is the best way to go. If you can stand to wait a little bit, then please send me an email or make an appointment. That's honestly my preferred way of contacting students, is by talking to you face to face. I would love it if you come chat to me at my office. So the link for this is right on Canvas. You can go ahead and click that link and sign up for it now if you want to. In fact, we're going to ask you to do that pretty soon as part of the little practice assignment that we're going to have you do. And I think I'm going to pause here before I move on to the next item and see if anybody has any more questions before I move on to the next thing. Any questions about policies, logistics? Yeah, right here.
What's the most severe penalty for an academic negligence?
And that's in the class. Yeah, that's the most severe penalty that I can give. And I often will do it. I mean, it depends on circumstances, of course, but I'm of the opinion that adults should know better, generally. And you can always ask before doing something suspicious. However, I want to make it clear that ChatGPT and tools like it are allowed, so that is not an AI concern for me. Don't care. So, talking to your friends, stuff like that, also less of a concern for me because, again, your friends aren't going to be there when you demo your assignment. Well, they might be there, but they'll be off doing something else, right? You're the one demoing the assignment. You're the one sitting to take that exam. So ultimately, you've got to show me that you understand this stuff. And I like seeing students talking to each other about their assignments. I like seeing students talking to each other about their code. Helping somebody fix their problems is a great way to learn coding, as far as I'm concerned. So that's great. Just giving somebody your homework assignment and saying, here you go, ship it. Yeah, I'm not a huge fan of that, but that's going to run into the same problem as if you let ChatGPT do your homework assignments. You're not going to understand how that code works. When somebody starts asking you questions, it's going to become pretty clear that you don't understand how that code works. So, yes, please keep these things in mind when considering how to approach the assignments in this class. Any other questions that I can answer? Yes? Yes, you can take this course pass-fail, and that's entirely up to you. So
what's
the cutoff for pass-fail is a 70, I believe. I think it's on the policies page somewhere. Yeah, here it is. It's a 70 for a pass. Yeah. Yes?
Are exams handwritten?
Yes, they're paper and pencil exams. I wish we could do them on the computer, but with this many people, it's just not logistically possible. So there'll be paper and pencil exams, yes. Yep, and there'll be a review session ahead of the exams where we talk a lot more about in detail what's on the exams. I can give you a hint right now, though. The quiz questions you're going to see, those are past exam questions. I mean, quite literally, rip them off the exams, put them on the quizzes. So you're practicing for the exams already. Yes? Absolutely, yeah. That's kind of what they're for, to check your understanding. I also post a big, giant practice quiz before every exam with bajillions of questions on it. So yeah, I'm a big fan of providing lots of practice resources to use. Yeah. Yeah.
What's the mean grade last year?
I have no idea. Probably an A. I give out a lot of A's. It's not a hard class. It's not a curved class either. I hate curves. I'm not a fan of curves. I consider this to be a competency-based class. If you can show me that you understand how this stuff works, then I'm going to give you the A. Right? Doesn't matter if your neighbor knows how it works or not. I want you to show me that you understand how to code. If you can do that, you're going to get an A. I don't care how many A's. If that means I give an A to everybody, great. I would love that. I would love for you all to walk out of here knowing how to code at the end of the semester. That'd be great. No limit on how many A's I'm going to give out. Any other questions that I can address before we move on? All right, so how to do well in this class. I mean, that kind of depends on your background, right? So some of you may find that, especially if you've had some coding experience, that you don't need to spend a lot of time grinding stuff before you come to class. You can just kind of show up and do a little refresher, and that's maybe good enough. If you haven't coded before, I would really, really, really highly recommend that you take a look at the coding exercises before coming to class on Monday. In fact, that's what we're going to spend the rest of today doing. So I didn't ask you to do any exercises before today. It's the first day of class. I'm going to do some exercises with you now. I'm going to do some coding exercises with you now. But normally, like if I go to Module 2 exercises, right, you can see at the top of the page, it's going to say that, you're highly encouraged for you to complete these exercises on your own before coming to class on Mondays. There's a link to a web page down here that contains all the topics that we'll be covering that week. So this is for actually week number 2, which we'll be doing after, not next week, because next week is Labor Day. The week after next, we'll be doing this one. So, you know, take a look at these for a couple weeks from now. It may look like a lot of stuff, but especially early on, the examples are going to be short and sweet. So each one's just going to take you a couple minutes at the most, right? As we move on and on throughout the semester, they'll start to get bigger and more complex. But at the beginning, you know, there's lots of exercises, lots of small exercises that we just kind of rapid fire throw at you. And there's code involved. So on Wednesday or Thursday, although you can start now if you want to, I mentioned this in my welcome email, you're going to be asked to install Eclipse, which is what we're looking at right now. I'm going to talk about what Eclipse is in a second. I'm just blowing up the text so that we can actually see things a little easier for this next part. Okay, cool. Yeah, so you're going to install Java, which is the programming language that we're going to be using this semester. There are many programming languages in the world, right? And if you take other intro programming classes, they might use Java or they might use Python. That's another very common language that people learn when they first start out. However, I want to make it clear that I'm actually not trying to teach you Java necessarily. I mean, we'll do that. That's sort of a side effect. I'm trying to teach you programming. I'm trying to teach you the basic building blocks of programming. And you'll see that, you know, once we learn what a variable is in Java, well, variables in Python look very similar, and variables in, you know, C look very similar, and variables in other languages also look very similar. So it's possible for us to take these programming concepts and apply them to any language we want. It's not such a hurdle if something's not in the language that we want. And then the last piece of this that I want to show you, these are the code exercises over here. Again, I know this might look like a lot, but this is actually 3 weeks worth of exercises, right? So the first week is this chunk, the second week is this chunk, and the third week is this chunk. So you're not expected to do all of these in a week, right? These aren't graded either, by the way. These are just materials for you to do to help improve your understanding. And then when you show up to class on Mondays, what am I going to be doing? I'm actually going to be going through these, right? Either just kind of going through the ones that I think are most important, or if you have one that's been giving you a hard time, I'd be happy to go through a specific one that people care about. But classes on Mondays is going to be all about reviewing code, writing code, looking at code, reviewing code. So this is what we're going to be doing, and for today, I wouldn't expect you to have this set up. I know some of you maybe did work ahead a little bit and go through the software installation and setup if you want to go through and get all this taken care of. The link to get the software installed and set up is right here. So you can click that link and follow the instructions. This is also what we're going to ask you to do in class on Wednesday and Thursday. So if you don't think about it until you come to class on Wednesday or Thursday, cool, that's fine too. For today, just sit back, relax, treat this like a demonstration. Don't feel like you need to keep up with me. You can't keep up with me anyway. I've been doing this for a while. Treat this like a little demonstration, and let's talk about some code. That's really what I like to do. That's what I care about. We're going to dive right in. We're going to talk about code. Starting with the very first example, this file that I clicked on over here on the left-hand side of the screen, you can see, well, maybe you can't because the text is kind of small. It's a .java file, .java file. So the .java files are used to store Java code. Surprise, surprise. And this is Java code. So this is about as simple as it gets for a Java program. This is like the bare minimum amount of code that you need to make the computer do something, make the computer do some stuff. This is what's known as a hello world program, right? Just basically says hi and then gets out of it. And so let's take a look at this real quick. Some of these pieces I'm actually going to be a little bit hand wavy about and just not spend a whole lot of time talking about because we're going to get to them later. We're going to do them later on in the semester. The first example is like this up here. Don't really need to worry about this line so much. You'll see it at the top of most files. It's basically the folder. You'll notice that it matches this little folder over here. So we don't really need to worry about that so much. This line is pretty important. This line defines what's called a class. Classes are something we're going to talk about much later in the semester. That's module 7. However, we have to use them. We can't just not use them in the meantime. It's a required part of Java. So for now, you can just understand that, okay, this is magic words that I need to make my program run. And then with inside of this, we'll see another what looks like magic words. However, this is the real stuff right here. This is what's called the main method. So whenever you see public static void main, what that means is that it's about to, this is the beginning. This is where our program starts. That word main is really your clue. Main is where our program begins. So I'm about to start a program, and then there are curly brackets, these guys right here. Anything that appears in the curly brackets, in between those curly brackets, we would say are the statements or the instructions of our program. This is the step-by-step instructions that we want our code to do. And it's going to go like a book, left to right, top to bottom. Just do them one after another, boom, 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 until it doesn't have anything left to do. In this case, there's just one thing for it to do. All it's going to do is say, hi there. So how do we actually make it do that? There's a couple of different ways you can do it, but the way I'm going to do it right now is by right-clicking the file, going down to Run As, and then selecting Java Application. It tells me that there's errors in the project. These errors are intentional. There are some files that are broken. We're going to look at those a little bit later, that we have some errors in intentionally. We ask you to fix them. So we don't need to worry about the errors. We can just go ahead and proceed, and we can see that, oh yes, it says hi there, right? But notice, this is an exercise, and the text of the exercise is right up here. It says, after you run this code, modify it to print your name. Okay, seems simple enough, right? But we're already kind of asking you to think about, get the courage to change the program to do something that you want it to do. This is programming. Programming is taking an example that you understand how it works and then modifying a little bit to make it do something that you want it to do. That's programming. That is programming. We're going to be doing that a lot this semester. So if I want to make this a little bit more personal to me, I can change it to my name or whatever name I want. Right? I can say hi to my kids or whoever you want to. Okay. Now, this is, like I said, about as easy as it gets. So, not doing anything terribly exciting. Let's see if we can take a look at some more stuff that Java can do. You might notice, by the way, that I skipped this example. That's intentional. I'm not going to do every example in class. I'm not going to have time to do every example in class. This is another reason why I think it's important for you to spend some time looking through these examples before class. So that if you really want to see me do an example, you can show up and be like, hey, I really want you to do that one, right? Make sure you do that one, because I will. I absolutely will if you ask me to do a particular example. But I'm going to skip this one and move to this one. And we can see that, unlike last time, there's 3 statements that all look kind of similar. One of them says to print the word hi, one of them says to print the word there, and one of them says to print an exclamation point, right? So 3 instructions that are going to operate one after the other, and you might think or suspect an output, but hopefully this is at least a little bit surprising to you what to see. The exclamation point is on the next line. And to understand why that is the case, we have to pay attention to the fact that there's a difference between these 2 commands that we're asking the computer to perform. One of them is just called print, and one of them is called println, where you can probably deduce that the ln is short for line, print a line. And so if we kind of reason about what this code is doing, when I just call print, the next thing that I print afterwards is going to be on the same line. When I call println, whatever I print after that is going to be on the next line. So if I want that exclamation point to be up on the top line with everything else, I can take the ln off, rerun the program, and we'll see that the exclamation point bounces way back up to the top. Right? So why spend all this time talking about how to format text and move an exclamation point around? That also seems like a very boring thing to have the computer to do. But I hope that this example illustrates computers are picky, very picky. They do exactly what you tell them to do. If I make a mistake and I use a print ln where I meant print, computer doesn't care. Computer doesn't know what I meant. Computer can't read my mind and be like, oh, you actually meant to use print there instead of print ln, right? It's not something that can happen. Not yet, anyway. I kind of hope it doesn't. Not in my lifetime. I don't want to think about computers being that smart. But the computer is going to execute exactly what I write, line by line by line. Let's do some math. Computers are great at doing math. So here's an example where I see that's multiplication. That looks like multiplication, right? So 570 times 23. I couldn't do this in my head. I mean, I could if you gave me enough time, but I'm not going to. So let's let the computer try and do it. And, okay. I mean, this isn't incorrect necessarily, right? Like 570 times 23 is equal to 570 times 20. That is a true statement, right? But that's probably not what we were looking for. It's probably hoping to have the results of that arithmetic computed and displayed there. Why didn't that happen? This is a pretty common mistake, pretty thing that I see often. You may have noticed these quotes around the stuff that we've been printing. If I take the quotes off of that one, we can see that I can run this code again, and I actually get, okay. There's the result of the computation. So what's the difference then between, having that written out with the quotes around it versus having it written out without the quotes around it? And the difference is actually one of the very important topics for today, which is the type. The type is different. So everything that we interact with in Java, everything that we interact with in our programs is going to have a type associated with it. Today I'm going to show you a few different types, but over the course of the semester we're going to see, there's literally an infinite amount of types, because you can make up your own if the existing types don't fit what you need. But we're going to start with the existing, the building blocks, the basic building blocks. There are two different types worth talking about here, right? When you see something in quotes, that is text, that is going to be treated as text. And so that's why when I have this in quotes, right, it doesn't do the math. It doesn't see it as math. It doesn't see it as a number. It sees it as text. It sees it as a text value. Okay? So anything that I see in quotes that's text, however, we don't call it text. We have a name for that. We call it a string. We call it a string. String with a capital S, as in a string of characters. That's why we call it a string. Text is a string of characters. If we take the quotes off, it's not treating it like a string anymore. It's actually going to treat it like the numeric value that it is. However, the computer is not quite good enough. The computer distinguishes between types of numeric values. This type of numeric value would be an int, which is short for integer. Whole numbers, right? Both positive and negatives. Those are in a separate category from non-integer values, or values that include decimal point, right? Values after the decimal point. So pi, for example, is very clearly not going to be an int. Those kinds of values have a different type. We'll see a little bit later on today, but just to kind of give you a sneak preview, those are called doubles. So if I have a value with the decimal points, that is actually going to be a double type. And knowing what the type is very, very, very important to understanding how the computer is going to see that value, how the computer is going to treat that value. This example already shows it, right? By putting quotes around something, the computer is going to treat that as a string. If I meant it to do arithmetic, I got to take the quotes out, and then the computer will naturally treat it as numbers, as arithmetic. Any questions? All right, great. Let's keep going then. The other thing that's worth mentioning, computers have, or languages, I should say, and this is true for the English language, the language that I'm speaking to you right now, have certain ways that they expect things to appear. So, if I speak to you, you expect the words to appear in a certain order, or if I were to write something down, you would expect punctuation, right? Period at the end of the sentence, or a comma in certain places when it's appropriate. The same is true for computers. The same is true for computer languages. It's called syntax. Syntax is quite literally where the punctuation and stuff goes. And so you've already probably picked up on it a little bit, and I've already kind of touched on some syntax stuff, but let's talk about it in a little bit more detail, because this is important. We'll notice here that the mistake that's made in this one is that I have the opening quote, but no closing quote, right? The closing quote is gone. And if you hover over this red underlined text, it says, string literal is not properly closed by a double quote. It's a very, techie way of saying you forgot the closing quote mark, right? But that word string, you can see that word already being used, right? That's a type. It's telling you that this string that you're trying to work with isn't closed properly. So in order to make this work, we just have to stick the quote in, right? Quotes always come in pairs. Always come in pairs. And as you can probably imagine, parentheses also always come in pairs. If there's an open parenthesis, there has to be a closed parenthesis. So these parentheses that are part of the printing, right? Those are non-optional parts of syntax. They have to be there. They're required. And then also, this semicolon, that's the period. That's the period at the end of the sentence. The computer is very, very nitpicky about this stuff. If I write you an email and I forget a comma or a period, you can probably still figure out what I meant, right? Humans can infer. Humans can look at that and be like, oh, there's probably supposed to be a comma there, or probably supposed to be a period there, or whatever. Computers aren't going to do that. Computers are not going to be like, oh, there's probably supposed to be a semicolon there. No. If you don't have the syntax properly written out, the computer's going to be like, I can't do anything with this. I don't know how to do this. The good news is that Eclipse does try to help you. So we saw the red underline there. Let's see what other kinds of errors pop. Oh, there's the parenthesis. That was actually, I spoiled this one. There's a parenthesis. What's this last one? So this last one is a twofer. The semicolon at the end is one, but be careful up here too. This S, that's lowercase. It needs to be capitalized. It needs to be capitalized. Code is case sensitive. Code is case sensitive, just like your passwords are, right? Gotta be careful about what's capitalized and what's not capitalized. Uncapitalizing the wrong thing, and the computer's not gonna know what you talk about. Seems silly, right? If I sent you an email and I forgot to capitalize the first letter of my name, you would still know who it is, right? The computer's not gonna make that leap for you. Who's that? I don't know who that is. I don't know what that is. Gotta be very, very particular. This drives people crazy, by the way. This is by far, I think, the most common reason that I hear people not liking programming, especially if you come from any kind of creative writing background, right? The rules are so loosey-goosey when it comes to writing English for humans compared to a computer. Super strict, super nitpicky, will not budge if one thing is out of place. So that drives some people crazy, absolutely nuts. But that's a fact. That's how it works. All right, let's move on. So far, we've just been telling our code to do something and then stop, right? Print out this thing and then stop. But our code needs to do more complex types of things. In particular, we need to be able to remember stuff. We need to be able to write stuff down, take notes. The equivalent of taking notes on a sheet of paper, so that later on, when I need that information, I can look at my notes and be like, oh yeah, that's what that value was, right? That's what this information was. On the computer, in code, the way to do that is by using something called variables. And so when I say the term variables, hopefully you start thinking of algebra class, right? That's a good association to make. That's really where the name variables came from. They are similar in a lot of ways, but different in some very important ways as well. This first line right here in this program, this is what's called a variable declaration. So before this line, before this line, no variables existed, none. After this line runs, we now have a variable, and it is called score. There is no value associated with that variable yet. It just keeps a spot for it, keeps the seat open for that variable. The next line that we see down here is the assignment. So this says, take the value of 4 and store that in the variable that is called score. So I'm taking a value and I'm assigning it to a variable. Let's take a look at these pieces in more detail. In order to do a declaration, I need 2 things. The first thing is a type. So the types we've seen so far, int, string. If you look down a little bit, you'll see an example of double, as I promised. Double's coming up. Those are the big 3. Well, there's actually one more that I'm hopefully going to get to talk to you about today. But those 3/4 types are the ones that we're going to be using for the first several weeks or so. So yeah, whenever I'm declaring a variable, I have a type. What type do I want that variable to be? Followed by the name. That's up to me. I get to make the name. I get to create the name. So you might think that it's fun to name variables like my 4-year-old names things. He would call this variable poop, right? He thinks poop is hilarious. He's 4. That's not a good variable name. It's a terrible variable name. Pick a name that is representative of what that value is. If this is meant to this very clearly tells me this value is meant to represent some kind of a score, right? For a game, I'm assuming. People like to use their friends' names. Okay, that's hilarious to you and your friends, but not very useful at describing what this value represents. So yes, you can name your variables funny things if you want to, but it's much more appropriate and better for everyone to name them something that is descriptive of what they are. And then for variable assignment, these lines can be tricky. It's important to always evaluate them actually from right to left, and also pay attention to the fact that this is not an equality statement. This is not an equality statement. This is an assignment statement. So what do I mean by that? I am not asking if score is equal to 4. That's a yes or no question, right? Either it's equal to 4 or it's not equal to 4. Here I am telling you, take the value of 4, store it in the variable called score. Put that value in. So take the value on the right-hand side of the equal sign, store it in the value on the left-hand side of the equal sign. That's how variable assignments work. Now, here we've split this up into 2 pieces, the declaration and the assignment. I almost never do it this way. This is a very technically correct way of doing it, but this is by far the most common way. Doing the declaration and the assignment all in one go. Type, name, equals, value. I'm going to create a brand new variable called price. The type of that variable is going to be a double, so there's a decimal point involved, and the value that I'm assigning to that variable is 23.25. So if you run this program, we'll actually see that even though I'm plugging in, this looks like a word, right? You might think, well, shouldn't there be quotes around that? Well, I can put quotes around that, but that's doing something a little bit different than what I had up here before. If I run this program like this, I'm not going to see 23.25. That was the value that was in the variable price, right? When it looks like this, it's going to recognize, oh, there's a variable called price, so I'm just going to plug the value of that variable in. That's 23.25. If I put quotes around it, anybody know what it's going to do instead? It's just going to print out the word price. Yeah. It's probably not what we want. Or maybe it is. I don't know. The computer will do whatever you tell it to, right? It's the beauty of programming. We can see down here, here's the 4th data type and final one that I'm going to introduce to you today. It's called a Boolean. A Boolean. Now that one is a weird sounding type, right? But it's actually probably one of the more simple types to deal with. Booleans can only have one of 2 values. So ints can be any whole numbers. 1, 2, 3, 4, 5, 6, 7. Doubles can be any value. They allow you to use decimal points. Booleans can only be true or false. That's it. True or false. Named after Mr. Boole, B-O-O-L-E, who was a mathematician from the 1800s, I want to say. Yeah, they're actually, turns out, very handy. And you can kind of imagine why. The true-false mimics, another very famous computer kind of concept of binary, right? Zeros and ones, trues and false, right? Those are binary kinds of concepts. And so it turns out Booleans are very useful when it comes to writing code, as we'll see a little bit later on today, and into Module 2 especially. Okay, let's start trying to take what we know about types and mix some things together. So what happens if I combine two types together? This is something that we actually will do periodically, or need to do periodically. Here, it wants us to write a print statement that, here's a big fancy word, concatenates. Concatenates. So concatenation is the act of taking two strings, and sticking them together. Let me show you what I mean by that by writing a little bit of code here. I'm going to put in a print statement, and I want to make this say, my favorite color is, and then tack this value on to the end of that statement. And I can use something called concatenation to do that. So I'm going to say, my favorite color is, and watch what comes next. After the quotation mark, I'm going to put in, that looks like a plus sign to me, but actually, well, I'll come back to that in a second. And then I'll type in the name of the variable. Plus sign, followed by the name of the variable. This is going to take whatever the value of this is and substitute it in. So it should stick this all together and make it into one big string. So this is not actually addition. This is not actually a plus sign. This is concatenation. This is concatenation. And this is another example of why types are so important. Because if I were to do something like this, int sum equals 2 plus 2, that is addition. 100%. That is addition. That'll give me 4, just as you would expect it to, right? But the plus sign on the following line, the plus sign right here, this is not addition. This is concatenation. Why? Why? The types. The types. 2 is what type? Int. And the other 2 is also an int, right? So when I have a plus sign that says, there's a number over here and there's a number over here, that's arithmetic, that's math. I can do that. Here, the stuff in quotes, that's a string. The stuff on the other side, actually also a string, right? Color is also a string. So that plus sign is going to look at it and be like, these aren't numbers. I'm not doing math. These are strings. I'm doing concatenation. The types of these things dictate the operation, right? Dictate the operation. What's more, so right now this says my favorite color is red. What happens if I do this? It's a little silly. It's a little bit silly. It's going to say my favorite color is 4. Well, okay. Well, let's think about what happened from the perspective of that plus sign right there. It looks on the left, it says that's a string. It looks on the right and it says that's an int. I don't want to do math with that, but I just can't do math with a string, right? How do you add the word hello? You don't. That's concatenation. So it's concatenation. Even if only one of the sides, even if only one of the 2 sides is a string, it's going to look at that and be like, this is concatenation. This is not addition. This is not addition. Does that make sense? The types of the values involved dictate the operation that's being performed. And so think about what concatenation means with other values. So here I gave you an int, and you can see that it took that int 4 and absorbed it into the string. So this is one big string, right? This is one big string that had that value of 4 from the variable concatenated onto the end. All right, that is probably one of the trickiest concepts that I'm going to talk to you about today. Are there any questions before we move on to, I got about 15 minutes left. Any questions before we move on to some more? Yeah. I'm sorry, can you say that one more time? Oh, I'm so glad you asked that. She asked about this space right here. Yes, this goes back to computers are nitpicky. I just stuck it in there out of habit because I knew that if I didn't, it's going to smash it, right? It's going to smash it in there. So yes, the spacing is exactly as I typed it. Exactly, yes. Can you store an integer? Yeah, that's a great question. Let me see if I can, so something like this, right? If I take 2 plus 2 and I store it in here, that is definitely doable. And look at what changes when I run this. All I did was I changed this to be a double from an int, and look at what happens. Oh, it tells me, it includes that decimal there. I can actually see 0.0, oh, that's a double. Right? Could it have been an int? Yeah, sure, but maybe I'm going to do like square roots or something weird with it later, so it needs to be a double, right? That's totally okay. Totally okay. But what about the reverse? If I try to do this and I say 2.5 plus 2, now I got a problem. Now it says you're trying to take 4.5 and smash it into an integer. You can't do that. That's a double. You have to make this say double to match. Yeah, question?
You said that we're going to be doing these before like classes, so would that be like the week before the Monday lecture or something?
No, so 2 weeks from today, you'll be showing up to review the Module 2 materials. So I'm hoping that 2 weeks from today, on Monday, you will have gone through these Module 2 exercises before coming to class. That's on the calendar as well, actually. The due dates of the exercises are class time, 1 o'clock on Mondays. So that's kind of my reminder to you to review them before showing up to class. But again, will I have any way of even knowing that you did that or not? No, not necessarily. I think it's in your best interest, but use your time the best way you see fit. Any questions about the code? Any questions about this example? Yeah?
Could you explain all the setup lines?
I could, and I will. I promise you I will explain this line and this line in a lot more detail. This line will be much easier for me to explain on week 5, module 5, when we get to methods. And this line will be much easier for me to explain on week 7 when we get to classes. So for now, I'm kind of asking you to just take a leap of faith, and these are the abracadabra hocus pocus that you need to make the code work. Yeah, I'm glad you're thinking about it though. I think it would complicate things a little too much right now. Yeah. Yeah.
If you were to do a double and say take a square root of like 2, how would you control like how many decimals it prints out?
Yeah, great question. So the question was, let's say I have a double that goes off. I mean, some of them go off forever, right? Some of them go off for infinity. How do I control how many decimal places I see? So that's kind of I'm going to approach that question. I'm going to answer a different question, and then I'll get back to your question. The double keeps as many decimal places as it can, right? So if yours goes off to infinity, like 1/3, obviously it can't do 3 forever. That's, it's a finite thing. But it'll keep as many as it can, which is quite a bit, right? Quite a lot. And then it rounds. So there will be rounding errors involved with doubles. That is actually, if you ever get into doing serious research with coding, that's one of our biggest things that we worry about is the rounding errors that are involved with the arithmetic. Especially for some fields, it matters quite a lot. But to get back to your answer, let's say you have a double with a whole bunch of decimals, and you're like, I don't care about all that. I just care about like the first two after the decimal place. Yes, you absolutely can. You're actually just basically saying to either round or chop off everything after the second one. You can do that too. So you would just say round to the second decimal place and then show me what that is. And it would still have, 0.25000000 at the end. I think if you really wanted to chop the zeros off, you could. Most programs that we do aren't going to care about that level of detail, though. Yeah, good question. Any other questions before I move on? Got about 10 minutes left, which is great. Yes?
Does this course have a textbook or like a workbook? Or are we just like...
You're looking at it.
Oh.
When you go and you click on Module 1 exercises, maybe I didn't do a good enough job of making it clear exactly what these are. There's a web page down here with this is basically an online textbook. And the first section is called Why Programming, Why Java? And that's actually what the name of this first section is, Why Java? So all of these exercises that some of them I did, some of them I didn't do, all of these exercises are going to appear on this page. And not only that, they're going to appear in the exact same order that they appear here, right? So this is the very first exercise of the whole book, and all on down. So I'm asking you to take a look at these before coming to class. Yep. So yeah, let's see. How do I want to spend the remaining time that I have? All right, cool. Let's take a look at more expressions. So variables are such a key part of any program. It is so important to understand how they work. Up here at the top, you can see that I create two variables, x equals 3 and y equals 2, right? So what does this line mean? There's a couple things to pay attention to here. One, a lot of people like to do this. A lot of people really want to see that word int there. It is true that x is an int. However, we only need to declare, right, the declaration. That only needs to happen once. So I said that x is an integer right here, the very first time that I declared it. The computer will remember that. I don't have to keep telling it that x is an int, right? I've told it that x is an int. It knows that. I don't have to say that again. Okay? The other thing to keep in mind here is that this is not, again, this is not an equality statement. I am not asking you if x and y are the same. That is not what that line of code is doing. Right? That's a yes or no question. The answer would be no. 1 of them is 3 and 1 of them is 2. This is a variable assignment statement. A variable assignment statement. Variable assignment statements are read from right to left. So what is that saying? It's saying take the value that is in y and put it in x. So the first time that I print out x and y, I expect to see 3 and 2. But the second time that I print out x and y, well, I said take the value from y and put it in x. It's going to take the 2 and put it here. They're both going to be 2. And we can actually run this to verify. Here's 3 and 2. That's the first two lines that get printed. I say x is equal to y, and now I see 2 twice, right? So take a value from one variable, copy it to another variable. If I come back and I change y again later, notice that x remains at 2. Only y has changed, right? So those variables are not linked in any such way. It is simply passing the values around from one variable to another. Another important way of updating variables that I want to show you. This line could throw people for a loop. This line can throw people for a loop. Remember, again, this is not an equality statement. I'm not asking you if those two sides are equal to each other. It's a variable assignment statement. So I'm saying take the value on the right-hand side and put it in the thing on the left-hand side. Okay, so let's work it out. Score at the very top on line number 7, you can see starts out at 0. I am saying take the value of score, which is 0, add 1 to it, so now it's 1, and then put that into the variable called score. So before this line executes, score was 0. After this line executes, score is now 1. It is simply modified itself. Right? We used its previous value to dictate its next value. This is okay. There's absolutely nothing wrong with this. In fact, An incredibly common thing to do. Incredibly common thing to do. So when you see a single equal sign, please remember that is not equality, that is variable assignment statement. So just to kind of wrap things up, because I know I am running out of time, what the heck is equality? I feel like I need to wrap up this story for you. What is equality? That is equality. That is equality. This question, this statement right here is asking the question, is age equal to years? Are they the same value? That answer has, there's only two things. There's only two possible answers, right? They are the same or they're not the same. What type does that sound like? A Boolean. So we're not going to see yes or no. We're going to see true or false. So when I say age is equal to year, that's false. That's a false statement. So it says age equal to year. They're different. False. That's equality. Double equals is equality. Single equals is variable assignment. Just want to repeat, I did not get through all the exercises for Module 1. That doesn't mean that you can't do them yourself. We'll get you set up with the software in Studio, and then it's still a week or two before we actually do any real assignments. So you got plenty of time. Let me know if you need any help, okay? Thank you.